solve advanced paper 1 section 1 question number 2. So the question is like this: for a reversible reaction, reactant giving rise to product, we have reactant giving rise to product. It's a reversible reaction. Both forward and backward reactions are first order elementary reaction with rate constants Kf and Kb respectively. What they're saying is it's a single step reaction and Kf and Kb are nothing but rate constant for forward and backward reactions respectively. At time t is equal to 0, the concentration of the reactant is found to be R naught and the concentration of product is found to be 0. That means at time t is equal to 0, the concentration of the reactant is R naught and this is 0. Okay. Then at any given time, R and P are the concentration of reactant and product respectively. So at any time interval T, the concentration of the reactant is R. This is nothing but left out concentration of the reactant and this is P. What is P here? P is nothing but the concentration of the product formed at any given interval of time. Next, if Kb is equal to, they have given a condition that Kb is equal to 4 times of Kf. If this is a condition, then the correct graphical representation of the following. Okay, so now they have given 4 graph. In all the graphical representation, I have just taken this as a reference. They have taken along y-axis, it is concentration ratio. What is that concentration ratio? If you look at it, so they have given product concentration by R naught, then reactant concentration by R naught. So these are the concentration ratio they have given. Among them, which is the suitable representation for this condition, we have to find it out. Simple. Since it is a reversible reaction, we can find out the equilibrium constant Kc. What is equilibrium constant Kc? Kc is equal to K forward by K backward, which is equal to K forward will write it as it is. Then K backward will be equal to 4 times of K forward. K forward gets cancelled. So we are going to get it as Kc is equal to 1 by 4, right? So we have Kc is equal to 1 by 4. But we want it in terms of reactant concentration. We want to find the relation between them. So that's why another definition for equilibrium constant Kc is it is the ratio of molar concentration of product by reactant at any given time t, right? So this is equal to 1 by 4. Therefore, from this, it is a very clear indication that R is equal to, the reactant concentration will be equal to 4 times of P. 4 times of P. So this is what the relation have got it. Then in the next, everywhere they have divided by R naught, I'll just divide it by R naught. Okay, so R by R naught will be greater than, because R will be greater than P. Therefore, this will be greater than P by R naught. Okay, so anyway, we know this. From this relation, it is very clear that suppose if I take the concentration of P as 1 molar, for every 1 molar concentration of P, the concentration of reactant will be equal to 4 times, 4 molar. Therefore, the ratio of reactant by product concentration will be equal to how much? It should be reactant by product concentration will be equal to 4 by 1. Okay, so we are going to get it as 4 by 1. Okay, now if I look at the graph carefully, if I look at A, that is graph A, there the concentration of reactant ratio and product ratio will be 0.5 and 0.5. So it meets like this. Therefore, it meets at what configuration? It is 0.5. Therefore, that indicates that reactant to product concentration ratio will be 1:1. That's not correct. Therefore, we can clearly say that A is the incorrect statement. Next, coming back to B. When I consider B, the concentration of reactant is said to be 0.2. Reactant concentration will be 0.2 and the product concentration will be 0.8. Okay, so product concentration will be 0.8. Product concentration is 0.8. Okay, so therefore it is a reversal of this, right? Therefore, they are saying that reactant concentration is less and product concentration is more, which is incorrect, because according to the relation, reactant concentration should be 4 times greater than the product concentration. Therefore, even the B statement is incorrect. Now I have drawn C. Okay, C graph I have drawn it. Just look at it. If I look at the graph C, in graph C, the concentration of reactant will be how much? It is 0.8. Okay, this is the reactant concentration. If I look at the product concentration, it is said to be 0.2. This is P. Therefore, I'll just find out the simplest ratio of this. What is the simplest ratio? It will be 1:4, which will be same as the whatever we have got it. Therefore, from this it is very clear that the answer will be option C. That is the correct graphical representation will be option C. Thank you.